Jai Hind students. So in the previous session we have completed the theoretical concepts involved in error analysis. Now in this particular session we will discuss some very important numericals based on the concepts which we have already studied in error analysis, and particularly the propagation of errors. We will discuss numericals based on the combination or propagation of errors. So let's start with the first question. Here I have written 3 questions. We will try to add some more numericals as well in this session. So let's start with the first one. In a simple pendulum, L, that is the length of the pendulum, is known to be 10 cm with 1 mm accuracy. The time period of oscillation is about 0.5 seconds. The time period of 100 oscillations is measured with a wristwatch of 1 second resolution. What we are supposed to find is, we are supposed to find out the percentage error in the measurement of oscillation due to gravity. Now look how to proceed like. Look, first and foremost, it's the case of a simple pendulum, right? In the case of simple pendulum, the time period is given by T equals 2 pi square root of L by G. L is the length of the pendulum, small j is the acceleration due to gravity, right? So what we do is, since we are supposed to determine the percentage error in small g, therefore squaring both the sides, what we get is T square, it would be equal to 4 pi square L by G, which further implies that G would be equal to 4 pi square L by T square. Now look students, as I told you earlier also, while dealing with errors, the term which is constant, it doesn't play any role, because the value of constant will remain unchanged, right? So the error in the determination of small g would be due to the error in the measurement of length and the time period. So 4 pi square being constant, it won't play any role in the determination of error in the value of small g. So now let's make use of the rules which we have already discussed in propagation of errors, right? So here, percentage error in oscillation due to gravity, it would be given by 4 pi square can be avoided, L to the power 1. So 1 times percentage error in the length plus 2 times T to the power 2. So 2 times the percentage error in the time period. Percentage error is the relative error multiplied by 100. The relative or fractional error is the absolute error divided by its true value, right? This we are already aware of. Put this as equation number 1. Now, let's read the question. L is known to be 10 cm. The length of the simple pendulum is given to be 10 cm. And it is measured with an accuracy of 1 mm. Students, it is in centimeter and it is in millimeter. So you need to convert millimeter into centimeter. So 1 millimeter is 0.1 centimeter. So this length of the pendulum is measured up to 1 correct place of decimal. So it will be written in this particular manner. 0.1 centimeter. 1 millimeter is the accuracy with which it is measured. So this is the true value and this can be the error, absolute error, right? 1 millimeter is written over here as 0.1 centimeter. Now time period. You are aware students, time period is the time taken by the pendulum to complete one oscillation, right? So here it's given, the time period, that is the time taken by the bob to complete one oscillation is 0.5 seconds. So true value is 0.5 plus minus. Now concentrate on this particular sentence. The time of 100 oscillations is measured with a wristwatch of 1 second resolution. 100 oscillations. And here we need to consider one oscillation, because that's the time period, time taken by the pendulum to complete one oscillation. So 100 oscillations, the resolution is 1 second. So therefore for one oscillation, the resolution will be 1 by 100 seconds. So it will be 1 by 100 seconds, that is 0.01. So it will be in seconds. Understood students? So now let's substitute the value and get the result. So del G by G multiplied by 100, it will give us 1 time del L, this is 0.1 divided by 10 multiplied by 100 plus 2, what is del T? It is 0.01 divided by T is 0.5 multiplied by 100. Let's solve it. So 1, it will be 1 only. percent plus 2, 100 get cancelled, it will be 2, right? So it will give us 1% plus 4%, that is 5% is the answer. So the percentage error in the determination of the value of acceleration due to gravity in this case would be 5%. So this is how you need to proceed, right? Okay, after doing this first question, let's consider the second one. Students, just consider on the second question. It is basically based on Ohm's law. V stands for the potential difference, I stands for the current, R stands for the resistance, and in class 10th you have studied for any given physical conditions remaining constant, the current flowing through a conductor is directly proportional to the potential difference. That is V equals to IR. That is the mathematical form of Ohm's law. So here VIR, I and V are given, so resistance is to be found, and it has to be expressed in terms of percentage error, right? So let's proceed towards the second question. So as I stated, here we will make use of Ohm's law. Potential difference, second question. Potential difference is given to be 100 plus minus 5 volt, right? Current, it's given to be 10 plus minus 0.2 ampere. So we need to find out the percent error in V, I and R. Percent error in V, del V over V multiplied by 100. What is del V? 5. What is V true value of potential difference? 100 multiplied by 100. So it is 5%. Clear? So percent error in the measurement of potential difference is 5%. Similarly, we can find out the percent error in the measurement of current. It will be equal to del Ix 0.2. This is 0.2. True value of current, that is 10 multiplied by 100. So it will be 2%. Isn't it? Now, we are supposed to find out the percent error in the measurement of R. Look student, what is the formula? R is equal to V by I. From Ohm's law, we are aware V is equal to IR. Therefore, R will be equal to V by I. Now, you must remember case 4. When the result involves the quotient of two measured quantities, then the percentage error in the result is given by the sum of the percentage errors in the two measured values. So what do you get is del R over R multiplied by 100, it will be equal to 1 time del V by V multiplied by 100 plus 1 time del I by I multiplied by 100. So what do you get? Percentage error in the measurement of potential difference is 5%, while percentage error in the measurement of current is 2%. So the answer would be 7%. So this was again a very simple question based on propagation of errors, right? So this is how the percentage error in V, I and R can be easily sorted out. It can be easily calculated. Okay, let's proceed to the third question. It's an interesting one. Look, a sphere is given, its radius is also given. Now radius is given to be 5 plus minus 0.1 centimeter. 5 plus minus 0.1 centimeter. Find out the percentage error in the measurement of surface area and the volume of this sphere. Now look students, the surface area of a sphere is 4 pi r square, isn't it? While the volume of a sphere is 4 by 3 pi r cube. So let's try to solve it. Third one. Let's solve it over here. Okay, this is the formula for the surface area. It is 4 pi r square. While volume, we are aware it is 4 by 3 pi r cube. This is the formula, isn't it? So, this being constant, while finding error constant term, it doesn't play any role. So, let's find out the percent error in the area. Del A by A multiplied by 100. It will be equal to R to the power 2. So, 2 times del R by R multiplied by 100. So, what you get is twice. What is del R? Radius is given to be 5 plus minus 0.1. 0.1, it's the absolute error in the measurement of radius. True value of radius is 5 multiplied by 100. So that will give us 4%. Just check it out. Point will get removed 1 by 10. So 100 by 50 is 2, 2 to 4. So the percentage error in the measurement of the area of this sphere when the radius is given by this will be 4%. Right? Similarly, let's try to find out the percentage error in the volume. So what do you do? Del V over V multiplied by 100. It will be given by, forget about this statement, it's of no consequence, r to the power 3. So 3 times del r by r multiplied by 100. So it will give us 3 times del r. Again, it's 0.1. What is r? It is 5 multiplied by 100. So it will give us, point will get eliminated. So 1 by 10, that is 1 by 50 multiplied by 100. 2, so 3 into 2, that is 6%. So I sincerely hope, students, such questions can be easily solved by you all. Isn't it? They're very, very simple, very important from MCQ point of view. So these are the questions which are directly based on the propagation or the combination of errors. Right? Okay, let's discuss some other very, very good questions. We have sufficient time for another 1 or 2 questions, right? So let's proceed with another question. It's again based on a combination of resistances, suppose. Again, you must have studied regarding the combination of resistances in series and in parallel. Suppose 2 resistors are given. One is having value of 5 plus minus 0.1 ohm. And let us consider the other resistor is having resistance of 10 plus minus, suppose it is 0.2, and the second one is having resistance of 10 plus minus 0.1 ohm. These 2 resistances are given. Now the question is, we'll consider 2 parts. The question is, these 2 are connected in series, and in the second case, the same 2 resistances are connected in parallel. So we are supposed to find out the percentage error in the resultant resistance of combination in series as well as in parallel. Right? So let's proceed with the first part. First part is when they are connected in series. When connected in series. You must be aware of the formula to be used in series grouping. Series means end-to-end combination like this. Right? This is R1, this is R2. So as I have told you, students, always remember, true value and errors, they have to be dealt separately. Now regarding true value, what is the resultant? What's the formula? It's given by R1 plus R2. And we are aware, whenever the result is given by the sum of the 2 measured quantities, then the errors are propagated in this particular manner. This was case 1, which we have discussed earlier. Am I clear? So these 2, real value and the errors, are to be dealt separately. Okay, let's find out the true value. What's the true value of R1? It's 5. What's the true value of R2? It's 10. So what will be the result? It will be equal to 15 ohm. Right? This is the true value. Let's find out the absolute error and the equivalent resistance. So del R1 is 0.2, del R2 is 0.1. So del Rs is equal to 0.3. So it can be expressed as R series. It can be expressed as 15 plus minus 0.3 ohm. This is the result in terms of absolute error. Now let's find its percentage error. Percentage error would be del Rs divided by true value multiplied by 100. What is del Rs? It's 0.3. What is the true value of the series combination? It's 15 multiplied by 100. So this get cancelled. 5 3 are 15, 5 3 are 10, 3 3 get cancelled. So we'll be left with 2%. Right? So the percentage error when the 2 resistors are connected in series, then the percentage error of the resultant resistances obtained to be 2%. I hope it's pretty clear. It's very simple. Now let's consider the second case. When connected in parallel. This is an interesting case when connected in parallel. So, in this case, what to do is the resistors are connected across such that the potential difference across each of these two resistors remains constant. So, this is R1 and this is R2. This is how the resistors are connected in parallel. Again, we'll divide it into two parts: true value and the errors, isn't it? So, what's the formula basically? We are aware in the parallel case, this is the formula: 1 by R parallel is equal to 1 by R1 plus 1 by R2. So, you can rearrange the terms and you can write it like this: R1 R2 divided by R1 plus R2. So, this is the formula for the parallel combination, right? So, let's find its true value. R1, what's the true value of R1? It's 5. True value of R2 is 10. So, what do we get? 5 into 10 divided by 5 plus 10. So, it is equal to 50 by 15, or it is equal to 10 by 3, which is 3.33 ohm. So, we have obtained the true value of the equivalent resistance of these two resistors when they are connected in parallel. It is found to be 10 by 3 or 3.33 ohm. Now, what we are supposed to do is, we are supposed to find out the percentage error. That's where an important case arises, because this thing, it comprises of product, it comprises of quotient, it also comprises of addition, right? All the mathematical operations are included over here. So it can be done in a smart way. Suppose this is represented by X and this is represented by Y, right? So what I mean to say is that R parallel, it may be written as X by Y, where X is R1 R2 and Y is R1 plus R2. Now what to do is, del R parallel, the percent error is to be found, this is to be found. So its power is 1, its power is 1. So it will be 1 time del X by X multiplied by 100 plus 1 time del Y by Y multiplied by 100. Isn't it? Put this as 1. So we need to find out del X, del Y, X, Y, and then we can substitute the value over there, right? So what is needed to be done is, X is R1 R2. Let's find R1 R2. So it would be R1 is 5, R2 is 10, so it is 50. X is done, right? What about del X? Now when it involves product, then del X is found by this formula. Del X by X would be equal to del R1 by R1 plus del R2 by R2, isn't it? So let's solve it. Del X over 50 is equal to, what is del R1? It is given to be 0.2 divided by 5 plus it is going to be 0.1 divided by 10. So let's find out. It would be equal to 2 by 50 plus 1 by 100. So further we get 2 plus 1 by 2, that is 5 by 2, that is 2.5. So we have found both X as well as del X from here, right? Next step is to find out the value of Y and del Y, and then we need to substitute the value of X, del X, Y, del Y over here, and that will give us the percentage error in the parallel grouping. So let's proceed and try to determine Y and del Y. Now let's consider the case of del Y. Okay. Y over here is given to be, or considered to be, R1 plus R2. Y is equal to R1 plus R2. So what will be its true value? R1 plus R2, it will be 15, 5 plus 10. What is del Y? In addition, we are aware it is, errors are proportioned in this manner. So it would be 0.2 plus 0.1. So that is 0.3. Correct, students? Now we have obtained all the value, right? This is suppose X, this is del X, this is Y, and this is del Y. Now from equation 1, let's substitute the values over here. So what we get is del R parallel divided by R parallel multiplied by 100. This is to be obtained. Percentage error in the equivalent resistance when they are connected in parallel. It is given by this formula. Let's substitute the value 1. Del x is obtained to be 2.5 divided by x is obtained to be 50 multiplied by 100 plus 1 time del y is 0.3 divided by y is 15 multiplied by 100. So let's solve it. This 2.5, so point gets eliminated, so it will become 500. So only 25 by 5, it will be 5. You can simply solve it. 1 point gets eliminated, it will be 100 by 150, 52, 53. 3 get cancelled, so we will be left with 2. So we will get 7%. Clear, students? So the second part, that is on the parallel combination, this was a very, very important concept, right? I will tell you an alternative method of doing this question as well. You can try this method in MCQs where proper time management is very, very important, right? So what to do is, let's do the same question and we'll get the same answer. So what to do is, you can do it directly. Instead of taking x by y, you can do it directly. Okay. Alternatively, what we can do is, over here, R parallel is R1, R2 divided by R1 plus R2. I am taking it as a single term. Right? These are the product and divided by R1 plus R2. It is to be taken as a single term. Now what to do is, del R parallel divided by R parallel. It would be equal to what? Product, R1, R2, product. This is product of R1, R2, numerator. So therefore it will be given by del R1 by R1 plus del R2 by R2. Right? Plus the numerator is over, denominator, its power is 1. I have taken this as a single term. So it will be del R1 plus del R2. This is the absolute error, total absolute error in this entire term, divided by the true value of the denominator. This is it. Now also if you proceed and substitute the values, you should get the same answer. Let's do it. So del R1 is 0.2, R1 is 5, plus it's 0.1 divided by 10, plus 0.2 plus 0.1 divided by 5 plus 10. Let's keep on solving it. So 2 by 50 plus 1 by 100 plus 0.3 by 15. Or it can be written as 3 by 150. It can be written in this manner as well. So let's take 300 as LCM. So it will be 12, 3, 6. So what we get is 18, 21 by 300. So this is del R parallel divided by R parallel. Therefore, what will be the percentage error? When fractional or relative error is multiplied by 100, then it will give us percentage error. So let's get the percentage error. Over R parallel multiplied by 100, it will be 21 by 300 multiplied by 100. So we will get 7%. So students, either way, either follow that method or this method, answer should be same. So here also the percentage error obtained is 7% in the parallel grouping of registers, right? I hope these questions you must have cleared your concepts, and these are the questions which are very, very important. So students, as I've always told you, I mean, here in this session I can do 1, 2, 3 questions related to a particular topic, but it's your job to practice as many numericals as you can, right? I hope I will be able to create interest in my subject, and please don't have any escapist attitude. Without numericals, physics is incomplete, right? So all the very best. We'll continue with the next session, right? Okay, thank you.